Welcome back everyone. So in this video, we will be working on another constraint problem, and this time the pattern should be something like this. It should start with 1, then 2, 3, 4, 5, and right after 5 it should be 5 again, and then 4, 3, 2, 1. So we have to generate this pattern using the system Verilog constraints. So the very first thing we would do is to calculate the total number of digits. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are total 10 number of digits. So we will begin with our constraint class. And here inside this, the very first thing we would mention is to write uh, a dynamic array of ints. Then we will write our first constraint, and since there are total number of uh, 10 digits, then we would like to use a constraint which would limit the size to 10 only. So here inside this constraint, I will name this constraint size, and inside this we would just use the size method. And the size should be 10. So this concludes our first constraint, and let's move on to the second constraint, which will determine the pattern. And I will call it a pattern. So what I'm going to do, first I will iterate through each element. So after doing this, I would put a condition, and that condition is going to be very simple. And the condition is, if the loop count iteration variable is less than 5, then if it is less than 5, then it will keep getting incremented. Here, remember, you could have used the post increment operator, but this does not work. This does not work with uh, the system Verilog constraints. So you cannot use the post increment or pre-increment or even post decrement or pre-decrement operators inside the constraints. So you just have to use the regular +1 style. So it is very obvious that if the element number is less than 5, then it will keep on iterating. So the very first thing it will print 1. So this will be the element number 0. So the element number 0 will be 1. And then the next element, which is going to be 1, it is still less than 5. So it will iterate, and it will just add 1 to it. So 1 will be added to 1 and it will become 2. Then for the next element, it will be 3. Hence for the next element, uh, it will be 4. And then for the next element, it will be 5. So after this, the iteration variable will be more than will be equal to 5. So what we will do, if it is equals to 5, we would just do nothing. So let me show you. So after this, as you can see, the pattern is supposed to first print the 5 for one more time, and then it will keep on decrementing. So there are various way, and the most simplest one and the compact one is to use just a second uh, is to just uh, assign all the later elements, that is the elements that are equals to 5 and more, with the size, and the size is 10. So 10 minus iteration variable. So this is the simplest way, and let's just find out what will happen. So what will happen when we get the iteration variable 5? So the fifth element will have something like this. The size of the dynamic array A, which is 10, minus the iteration variable itself. So 10 minus 5 is 5, and it just satisfied the upcoming element as per our pattern. So let's move on to the next one, and the next one will be 6, and the similar thing is going to happen. So the size is 10, 10 minus 6 is 4, so it will become 4. Then the next one will be 7, and for 7 also it will happen like this. The size of the dynamic array A, which is 10 minus 7, and we will get 3. Then simultaneously for the next one, which is 8, we will have 10 minus 8, which is 2. And then finally for 9, we will have 10 minus 9, which is 1. So if you follow this, we just get the other half of the pattern, which is mentioned right here. That is 5, 4, 3, 2, 1. And it is also 5, 4, 3, 2, 1. So joining them together, you can see that we are getting the correct pattern. So what I basically did, I just divided the elements into two halves. The first half will keep getting incremented by 1, and the second half, you just have to um, subtract whatever the iteration variable is with the total size of the dynamic array. And by that way, you will just first stop at 5, and then it will keep on decrementing until 1, where we will reach the end of the dynamic array. So let's go ahead and write our display method inside the post randomize function. So here I will write our display system task. And I will use %p to print the elements and A. So let's begin with our main module. And first I will declare the handle, and inside the initial begin I will assign the object. Then I would just put the randomize inside the immediate assertion. Else that will give an error. So yeah, oh, it should be else, not s. So first, let's just compile the code and check whether we have made any compilation errors or any typos. Okay, there is an error. Oh yeah. Okay, so this there should be 2 equals to, and it is because inside constraint, if you want to use the assignment operator, you should be using two assignment operator, just like you will use in regular if else conditions. So that's why it was showing an error. No, it's fine. So let's run the simulation. So you can check it right here that we are getting the desired pattern of 1, 2, 3, 4, 5, and then 5 again, and then 4, 3, 2, 1. So for such kind of pattern in which the elements are kind of mirroring, as you can see that after 5 it was 5 again, and then it was actually the opposite. It started getting decremented. For such kind of scenarios or patterns, it is better to divide the elements uh, into two parts, into actual half. So the first logic was quite simple and straightforward. You just have to increment every elements by one. And the second logic is also very simple. You just have to think about it for a second, and you just have to try to imagine. You just have to try to imagine a formula in which this pattern can be generated, and that's the formula. You could have written. You could just write 10 right here, and it would just work fine. So that's all about another constant question, and stay tuned for more. Thank you so much.